What's up, friends? Happy Wednesday night here on the East Coast of the United States. My name is Whitney or Whit. I am a GMAT, Jerry, and executive assessment instructor here at Manhattan Prep. It is 8 o'clock. It is still sunny out. You got to love that it's middle of summer. It is July 10th. So here we are, mid-year. I am really excited about tonight's lesson. We are going to be doing a quantitative lesson around a strategy that I think doesn't get the love it deserves. I think people often expect a question to be kind of most questions to be done with algebra. And if you've been hanging out with me here on YouTube or the free prep hours, you will know that I love my algebra. I do, but I also want to make sure that I have scrappier methods available because the GMAT will, technically punish us sometimes for using formal algebra. Yeah. So we're going to get started. Let me go ahead and share a screen for you. So again, my name is Whitney or Wet. Either one, feel free. Tonight's lesson is on one of my favorite topics, the concept of working backwards. Now, I have this listed primarily under the quant section, but it should be known that we can absolutely use working backwards, particularly in the DI section, the data insight section, particularly for two-part problems that are behaving very much like quant problems. So we often will use kind of these same concepts of working backwards. But I think that people often think work backwards and they don't really have a clear picture in mind of what that means. So what I'd like to do tonight is call out what I think of as like working backwards, and it's anything that involves me using the answer choices. Now, candidly, I'm always looking at answer choices, right? I'm always taking them into consideration. But in two sort of very specific scenarios, I'm actively working with the answer choices. One of those would be questions where I'm taking answer choices and plugging them in, right? Kind of plugging them back up into the question. And in the other family, I'm using my answer choices to help me estimate, or I'm benchmarking off of my answer choices in order to save myself computation. Because reminder, on the quant section of the GMAT focus, we do not have a calculator. On the data insight section, we do, but we don't for quant. And so for those questions, for those 20-ish questions, we need to be ready to get to answers without cranking numbers, ideally. So I want to start with just kind of a generic word problem, just for fun, just to try it out. And I want to encourage you, if algebra is your thing, like fine, go nuts. We'll talk about a variety of ways to solve this problem, but I want you to give it a go. Now, our general timing for quant questions is right about 2 minutes. And so I'm going to put a timer on the clock for you, or on the screen for you, counting up. And I'm going to cut us off at like the 2.5, 3 minute mark. Yeah. So when you've finished, I want you to pull in to me the answer that you got. But more importantly, I want you to tell me, what kind of methodology did you use? But here we go. Here is your first question to try. Let's give it a go. Okay. All right. So far, I am looking at no answers. I don't have any answers in. So how does this question feel? I want to hear from everybody in the chat window. What do you think the answer is? If you don't have an answer, why not? What's making this problem particularly tricky? Okay. So I'm getting some comments about not knowing how to set up an equation. So show of smiles or hands if that's you. I'd love to see reaction. If you are also someone who doesn't necessarily feel comfortable setting up the equations here, knowing how to set up the equation. Yeah, for sure. Yep. Oh, okay. And then I had someone who set up the equations, but then the math got really, really ugly. Did anybody get that far where you were setting up equations, but now the math was really bad? Yeah. Yeah, it's so ugly. All right. Well, so good news. We're going to come back to this question. We're going to come look at it in a minute. Before we do, I want to try a couple of less obnoxious questions. Yeah. So what I'd love to do is give you a much friendlier question to try. Right? So try this one however you would like. Same kind of timer coming your way. Right? Same timer coming your way. And I want you to solve it however you want and then submit an answer. Okay. And if you haven't given me an answer yet, please do. This one seems much easier, right? This is a lot faster. I got a bunch of answers in really quickly. So talk to me. What was it about this question that seemed so much easier? Because I would agree, it is easier. But why? What about it made it so much simpler? Setting up the equations was easier, for sure. Solving the equations. What was it about these equations that made it so much easier? Yeah, so these seemed like they were like simple lines, right? Simple line equations. There weren't any variables getting multiplied times each other. Absolutely. Absolutely. And so if you set these up with algebra, but let me ask you this. Before you've even done any algebra for this problem, right? Any at all, are there any answer choices that just absolutely would not, under any circumstances, make sense? What do you think? If you were to have taken a quick scan down and looked at answer choices, are there any that just like weren't possible? Yeah, absolutely. So my question is asking. So one of the first things I always do when looking at questions. Now we're going to start to practice a little bit of technique. Okay. When I'm working on a multiple choice question, the very first thing I do is I look at the answer choices. It's the very first thing I do before I even read the question. I look at the answer choices, and there'll be things that I'm looking for. Are there variables in those answer choices? If you've taken some of the earlier free prep hours with me, you'll know that if there are variables in the answer choices, that's one of the signals to pick our own numbers. Okay. Well, another thing I'm looking for in my answer choices is, are they nice, clean, easy, simple values? That's also a really good signal. Clean, simple values might mean that if I wanted to plug answer choices into my problem, I could, right? Without too much of a pain. Also, right, if I start looking at my answer choices, it's like if they're really spread out, that might give me an indication of whether I can estimate or what I might call benchmark my answer choices. So these are both clean and simple, right? 2, 5, 7, 12, 24, and they're pretty spread out. So just looking at the answer choices, the first thing I'm going to consider is that if I wanted to plug in answer choices, these wouldn't be bad. And they're kind of spread out. So if I want to estimate, I can do that too. The second thing I do for all multiple choice questions is go to the question itself. And I look at, like, I follow the kind of question mark symbol back to the start of its sentence. And that's what I read. Right? If she did something, question. How many pairs did she buy? So this is what I would call a single plug-inable value, right? So in this case, it's like, I think of this to myself as potentially plug-inable. If this question had instead said something like, what is the average of the number of pears and apples that she bought? Right? Or they ask for some, what is if they ask for something more complicated, like a combo of things, a combination of items, that may not be plug-inable. Might be, but it may not be plug-inable. So if a question is asking for a single value, a single variable, right, a singular concept, that might be something that I could plug back into the problem. The combination of potentially plug-inable question with really clean answer choices tells me, right, this kind of combo with my clean answer choices tells me that this might be, if the algebra is kind of a mess, a good problem for me to work backwards by taking my answer choices and literally plugging them into the problem above. Right? Like just like literally sticking them into the problem. Okay, so I've kind of made that assessment. Now I'm going to read the question. Now, if you saw this as easy enough to set up algebra, fine. But we're not going to do any algebra tonight because I want you to practice, or we're not going to do any heavy lifting algebra. I want you to practice with this concept of looking at your answer choices and using them. So if I know that she bought a total of 12 pieces of fruit, apples and pears, and there's a relationship between like apples and pears where she bought more apples than she bought pears, then she certainly couldn't have purchased 12 or 24 pears because she got more apples than pears and she only got 12 pieces of fruit. So it wouldn't make sense, right, that she bought a total of 12 and she bought more apples. She can't have bought, 0 apples and 12 pears. And so I can actually get rid of both of these answer choices. In fact, I can also note that because she bought more apples than pears, the number of pears has to be what? Less than what if she bought more apples than pears? So what would logic tell me it has to be? Exactly. Apples have to be less than half, right? If I only bought 2 things, apples and pears, and I bought more, excuse me, not apples, pears have to be less than half. If I bought more apples, apples are going to be more than half. Put it down that way. Apples would be greater than half, and pears would have to be less than half. So there goes yet another answer choice I could get rid of. From here, I could just start to test out my answer choices. So note that this is asking about the number of pears. So if she bought 2 pears, so here's where plugging in, we get some choices. Okay, so I want you to see that there are a couple of ways that we could plug in once we're down to, let's say, 2 or 3 answer choices. So I'm going to put C back on the table just so that we've got it. But let's imagine, right? And so again, I'll give us like 2 different ways. And so you can see how it really doesn't matter how you kind of start and proceed through working backwards. They'll all roads lead to Rome, so to speak. So we know that the answer choices represent the number of pears. And I have 2 relationships. This is my number of pears. And I'll do this other one over here with my number of pears. Okay. And we'll say that we've already kind of outsmarted the question and gotten rid of 12 and 24. So I have 2 different relationships that relate pears to my other unknown in the problem, which would be apples. I have the fact that Jean bought a total of 12 apples and pears, or I have the fact that she bought 2 more apples than pears. It doesn't actually matter which relationship I start with. I'm going to pick whichever one mathematically seems easier. And so I'll start with this. I'm going to do it both ways. So imagine I decided to start with the total of 12 apples and pears. If this is my number of pears, then according to this green sentence, my number of apples is whatever number brings me to a total of 12. So I would have 10 apples or 7 apples or 5 apples. From there, I'm going to check with the remaining relationship and ask, in this scenario, does she have 2 more apples than pears? No. In this relationship, does she? And so it has to be this one. This is the only relationship where she has 2 more apples than pears. Note, I could do the exact same thing if I had started with the blue sentence and said, okay, she bought 2 more apples than pears. So if she bought 2 pears, that's 4 apples. 5 pears, that's 7 apples. 7 pears, that's 9 apples. And then I could come back and check it with the other relationship. This time it would be the total. And does 2 plus 4, no, that's 6, so that's not right. 7 plus 5 is 12, so that's my correct one. So for this next question, right, the algebra, not crazy, right? Definitely not crazy. What I want you to do is to, instead of trying the algebra, I want you to slow down and imagine, how might you do this problem backwards? How would you go about using the answer choices in some way? Could you even eliminate a couple of answer choices, right? Doesn't have to be a bunch, but could you eliminate a couple of answer choices? Okay, here we go. Let's give this one a try. All right, if you haven't given me an answer, pull in with at least a guess. With at least a guess. All right, so how did this one feel? I'm sure, honestly, the algebra was probably wildly easier than thinking about working backwards. But what did you notice? What were some elements that you could use to maybe eliminate a couple of answer choices? Okay, so we know that there's a total of 115, and the green lot holds fewer cars than the red lot. Okay, so again, let's check our answer choices first. Clean, simple numbers. These three are a little close together, but these two are close but further apart. So maybe we could like group or lump them if we estimated. And the question is asking for a really simple plug-inable value. How many cars can one of the lots hold? Okay. I know that the green lot is smaller than the red lot. So a half of 115, well, a half of 120 is like 60. So like, let's say 57, 58, somewhere in there. Notice that 60 is close enough. It's a good benchmark. We're going to talk about benchmarking. So it means that like my midpoint is about, let's call it like 58, something like that, 59. So the number of green cars has to be less than that, and the number of red cars has to be greater than that. Well, looky there, I have a nice split. I want red. That's what all of these are asking for, is the number of red cars. And so it can't be A or B. Those two are totally out. So I can use either relationship to go, right, like to figure out. I can go from red using the to green, finding the 115 cars. I'm going to use red to green using the minus 35 because I don't know, that feels maybe easier to me. So the green lot's going to have 35 fewer, which means that in this scenario, the green lot's only going to have 35 cars. In this scenario, it'll have 40, and then this one would be 45 cars. And now I'm going to check it using the fact that they have to sum to 115. 70 plus 35 is too small. 75 plus 40 is, in fact, 115, and that's my answer. Now, just as a heads up, I just as easily, right, depending on how you see the relationships, I absolutely could have chosen my green based on the other relationship, based on the total of 115. So I could say, okay, to go from 70 up to 115, I'd need 30 to get to 100 plus another 15, so 45. 75 up to 115 would be 25 to get to 100 plus another 15, so this would be 40. And this 80 to get up to 115, 80 plus 20 plus another 15 is 35. And then I would ask, does the green lot hold 35 fewer than the red? Well, be careful, 35 plus 45, 30 and 40 is 70. Those two fives lump me over to 80. That's too big. 75 and 40 is my one that works. So generally, when we're using working backwards on problems like this, you're often in a situation that might be like a two variable situation where you've got would be two equations where you're solving, where you plug one into the other kind of thing. And so you'll potentially have a scenario where you've got one relationship that you can use to calculate and then another relationship that you can use to check. They can get more complex, but if you don't have a solid algebraic way to go about solving it, it can be a lifesaver. So I want to take us back to Misha and her toothbrushes. Yeah. And I want you to take, and my answer choices are wonky for these. So let's go. I don't know why my Misha toothbrushes. My apologies for the earlier question. That'd be really hard to answer. Misha and her toothbrushes. 1 second. Let me get you the right answer choices for those. I must have mistyped them. Here we go. So we got $1, $3. What do I have? $4 and $5. And we'll go $6. Okay. So I've got Misha and her toothbrushes. And I want you to, right, like take note. We've got relatively easy answer choices. And they're asking, how much did she pay for one toothbrush? That's a simple price. So give it a try. I want you to see what might happen if you use the answer choices, plugging them in for this problem, and see what answer you get. I'll set a timer again for you. Okay, if you haven't sent me an answer, please do. Got answers from almost everybody. Nice. Perfect. Okay. So if we look at this problem as having nice, clean, easy answer choices that are, okay, this is how much she paid, right? This is the price, original, right? Like, so this is like the OG price. This is our original price. Then I have a couple of ways I can proceed through this problem. From the original price, I can also calculate the new price, like the discounted price. But from the original price, I can also calculate how many toothbrushes she was originally able to get. And so maybe I'll start with that. I'll start with like my original price and then my original quantity. Okay, so if my original price was $1 and I was spending 60, I could buy 60 toothbrushes or 20 toothbrushes or 15 toothbrushes or 12 toothbrushes or 10 toothbrushes. Note your small multiples of 15. The GMAT uses them all the time. Okay, those are my original quantities. I have a couple of options. I can, and the one I liked for this is just, I'm going to use the new discount for the discount price and the, discounted quantity. So I'm going to go back through these numbers and say, okay, to get my discounted quantity, I need to take my original quantity and I need to buy 5 more. So my discounted quantity, I had to get 65, 25, 20, 17, and 15. My discounted price, if I saved $1, wait, hold on. That means in answer choice A, they'd be free. Okay, well, that wouldn't make any sense because if they were free, I could buy an infinite number. So A's out. In this case, they'd be $2, $3, $4, and $5. And my job now is to figure out which one would cost me 60 bucks. Well, 50 is too low. There's my 60. Notice that this problem ends up without a lot of crazy scratch work. We just have to follow the story by plugging every answer choice in. And here's where I will say, often the suggestion, and we often at MPrep too, give the suggestion of starting with B and D, using those to sort of benchmark. I'm going to suggest that while you're practicing working backwards, right, while you're learning, that instead you just plug in all the answer choices so you can get more practice. The way I do it, as you notice, I do one specific issue at a time, right? So I didn't take answer choice A and run it through everything. So I didn't like start with A and come up with quantity, discount price, discount quantity, and come across. I did one operation on my answer choices at a time. Generally speaking, I find that that's the easier method to just, I'm going to test out my answer choice. I'm going to test out this one thing. Okay, from price, I get quantity. Do that for all of them. From those, I get a new price. Do it for all of them. From those, I get a new quantity. Do that for all of them. If you then eventually decide that you're going to do that same thing, but you just do it for choices B and D, it means that you only write the numbers for B and D down on your paper, and then you test those. From there, you can tell if something is like too small or too big, and you can kind of move in different directions. But this is not the only way we use our answer choices. There are a lot of ways that we can use our answer choices really powerfully. So for example, a problem like the following. So give this one a go. And pull in when you think you've got it. So I'm getting answers really quickly for this one. And partly it's because the question's not crazy hard. But take a look at those answer choices. Yes, they're clean, easy numbers, but even more, They're way spread apart, right? And they're spread apart by like powers of 10. So it's like 216 and 2116. So this is a really good sign that I could estimate and kind of like, ballpark it. So I want the total sales for this company in Q1. Well, I know that Q1 is 18% of 1.2 million. Well, here's the deal. If Q1 sales are just 20%, which is about a fifth, right? So think about 20% as being like 1/5, or, right, 20% is 10% times 2, right? It's going to be a lot smaller than a million. So there's absolutely no way that my answer can be 2 million. I'm not going to make $2 million as a fifth of a million. And if somebody were to come up to me and be like, I'm going to give you a fifth of $1 million, well, like half of $1 million is 500,000, right? Half. A fourth of $1 million is a quarter of that. So that'd be about $250,000. This is looking pretty good. Okay. Alternatively, I could say $1 million, 10% of $1 million is moving the decimal point one space. So it's $100,000. 20% would be about $200,000. It's definitely going to be more than $200,000 or $2,000. And we can probably tell it's more than C as well. Okay, so we can use the answer choices, right, themselves, right? We can use estimation on the answer choices themselves. Another way that we can use estimation, and it gets used quite frequently, is in the world of roots. So give this question a try. And I should note that memorize your roots. Square root of 2 is 1.4. Square root of 3 is 1.7. Square root of 5 is 2.2. And anything else is just nearby another known root. All right, if you didn't get me an answer, please do. How was this one? I got a couple answers in really quickly, and a couple took a lot longer. So If you're really comfortable with the math of square roots, fine. But what I want you to know is that the test doesn't actually expect you to be all that comfortable with the math of a square root. That for most questions where a square root is involved, particularly if there are no variables, you can absolutely estimate. So for example, what is the square root of 48? Well, I have no idea, but I can benchmark it, right? So when I say benchmark, I think about things like this. Like, okay, I know that the square root of 25 is 5. And I know that the square root of 36 is 6. And I know that the square root of 49 is 7. So that means that the square root of 48 is going to sit in here. And the square root of 27 is going to sit in here. So the square root of 27 is, or the square root of 48 is pretty close to 7. And the square root of 27 is pretty close to 5. So my answer is going to be like pretty close to 12, right? Because it's a little more than 5. That's a little less than 7, like close enough. My answer is going to be about 12. If I know that the square root of 3 is 1.7, that's basically like increasing whatever it's multiplied by like 50%, technically 70%, but it's like adding another half on top of what I started with. So if I take 7 and add a little more than half of 7, think 7 plus 4-ish, right? So this is going to be 7 plus 4-ish. That feels pretty good. This one's going to be 19 plus like 11 or 12-ish, right? Like it's like half of that. That's way too big. 12-ish. This is huge, right? This one's big. Same problem with C, right? I'm taking 25 and then adding like half of that to it. So like 12 or 13, at least more than that to it. So this is too big. I'll come back to 75 in a second. And 57 is just, way too big. Like I'm looking for 12, not 57. So I got to do a little more benchmarking to get out the 75. Square root of 8 times 8, right? 64. So 9 times 9, 81. Right? So there's my 8 and there's my 9. That means that the square root of 75 is somewhere benchmarked between these two. Right? And so this is going to be a number around 8.5, maybe, let's call it, which is too small. It's also the trap. They want you to think you can just add those two numbers together. And so my answer has to be A. So we can use estimation of the numbers, right? We can also use benchmarking to help us estimate. So what I'd like to do is show you a question where we're actually going to use the same concept of benchmarking, right? Where you're like, well, this is too small and this is too big, so it's got to be here. We're going to use the same concept of benchmarking in order to, on the answer choices, in order to assess the answer choices themselves. Yeah. So here we go. Let's give this one a go. Okay. So answer choices that are percents are a great candidate for benchmarking. especially if those percents are relatively far apart or spaced around really easy percents. So when I see this list, here's what I know. I know that they're trying to catch me by dropping a 0 somewhere. So instead of thinking of 30 and 3 and 0.3, I'm going to think of easier percents. I'm going to note to myself that that might be a possibility, right? Because all 10% or 1% or any of these, all of these are just a move of the decimal point. So much easier to calculate. Okay, so here's what I know. I know that in a certain species of salamander, this mutation occurs in 13 out of 4,000. And they want me to try and assess, like, what percent is 13 out of 4,000? Well, I'm going to use this numbering. So if I've got 4,000 people, or 4,000 individuals, salamander individuals, 10% would knock 1 0 off. That would be 400 salamanders. Too many. 1% would knock another 0 off. So we're getting awfully close. And then if I went down to 0.1%, I'd knock off one more. Well, my actual 13 is between 40 and 4. So my correct answer must also be between 40 and 4. And so my correct answer has to be answer choice C. Note that E is the trap answer. If we look for what a percent, how that, 0.3%, writing that as a decimal would be 0.003, but with the percent symbol, it's 0.3. Right? So genuinely, if I have answer choices that have percents, I'm way more likely to benchmark so that I don't miss a decimal place, but also so I can just save myself some miserable math, honestly. Okay. I want to look at one more of that type, and then I want to show you a final way that you can kind of use this same estimating and benchmarking in certain types of questions. So let's take a look. This is a great question for just like estimating across the board, knowing that you don't have a calculator. So here we go. Give this one a shot. If you didn't pull in yet, please do. Okay, so this table is giving us a bunch of books. And then we're being asked what percent of all of the books are categorized as other. So this would be like 9,000 over some number. Now you might be looking at this and thinking like, holy cow, these numbers are so ugly. Right, now I'll actually make us a little more space. You're right, these numbers are pretty ugly. The uglier the number, the more I'm meant to estimate generally. My answer choices are also pretty spaced out in terms of percents, right? I've got 10% right here. I've got 2 between 10 and 20, but 15%, the halfway point, would split them, so that's okay. And then I've got 30% right here. So I could pretty easily split my answer choices with easy percentages. So I need 9,000 divided by the total, or I need to figure out how many total books there are. So I'm not going to round anything. I'm going to sort of think a little bit about how to pour and combine numbers together. Like, for example, this 2,300 and this 2,800 are pretty close, or 28,000, excuse me, are pretty close to making 30,000 with like some overflow. So I'm going to take that overflow. I'm going to take the overflow with the 69 that's sitting up here, and I'm going to take the overflow from the 35,000. I'm going to give all of that, it's like 500, 600, 700, 800, 900. It's about 1,000. I'm going to give that about 1,000 to the 9,000 and make it 10,000. Which means my denominator is now 3, 4, 5, 6, 7. So I've got 75,000, which I can just knock off my zeros. So I want to know, like, what percent is 9 of 75? Now, there are some fun tricks we can use to reduce this fraction and figure it out. But I could also look at my answer choices and say, okay, 75, what percent is 9 of 75? Well, 10% of 75, move the decimal point 1, would be 7.5. That's awfully close to 9. But it's still too small, so A is out. If I go all the way up to 20, it's doubling 750. So $7.50 doubled is $15. So now I'm too big. 15 is way bigger than 9. So it's definitely not D and it's definitely not E. The question is the number 9 closer to 15 or closer to 7.5? Well, it's only 1.5 away from 7.5. It's like 6 away from 20. So my correct answer has to be B. And there we have it. Right? So we can use this kind of like benchmarking tool to be able to kind of estimate with our answer choices. So there is technically one more kind of way that we can work backwards, and it's on like very specific average question types. Right. And so some of these average question types, we've already done some free prep hours on, so you should actually go check them out. I did one just a little while ago on rates and work. And so like combined work problems are a great one to average. We're about to try one. But they also work really well on weighted averages. I also did a lesson this year on weighted averages, so go check that out. I show how to estimate, right, and how to benchmark. So we're going to do one of each of those really quickly so you can see how they work. And so an example would be the following question. Right. So give this one a shot. Okay, there we go. Got a bunch of different answers coming in. A lot of changes. A lot of changes. So there are much more formal ways of solving a problem like this. And I want you to take a look at our weighted averages lesson for more practice. But I want you to know, like, this is a really quintessential weighted averages program, like problem, where it's like, okay, I have, a Wednesday, like a Tuesday, right? If I look at all my Tuesday boxes, I've got 200. And on Wednesday, I shipped 300. Now, on Tuesday, 35% were premium paper, but on Wednesday, only 25% were premium paper. So here's the thing. If I'd only shipped paper on Tuesday, then the percent of the boxes shipped that were premium would be 35%. If I only shipped boxes on Wednesday, then the answer to my question would be 25. So it has to be the case that if I'm blending together Tuesday and Wednesday shipments, then those shipments have to look something like the smushed average of these. So it's not going to be 35, it's not going to be 25, it's going to be somewhere in between. So I can eliminate any answers that aren't between 25 and 35. So I can get rid of E and I can get rid of A. But with weighted averages, I can also sort of look at this space as like, you know what, if Tuesday and Wednesday were the same day, meaning I had shipped 300 on both days or 200 on both days, then the average would be a straight average. It would be 30%, premium paper. However, they aren't perfectly symmetric days, right? Like Wednesday was a bigger day. So Wednesday is going to have a bigger impact on that overall look. And so I'm going to get pulled in the direction of 25. And so I know the answer isn't D. So then the question becomes like, how much closer to 25? Well, I've got like 50% more, right? So it's more, but it's not like a crazy number more. So it shouldn't be that it drags me all the way down to 26%, because that looks almost exactly like Wednesday. Like think it's 1 percentage point away from Wednesday, but it's 9 percentage points away from Tuesday. That means it looks 9 times more like Wednesday than it does Tuesday. That's not right. I only have 50% more, not 9 times more. And so if I've only got like 50% more, it should look like a little bit more like Wednesday. It doesn't even look twice as much like Wednesday. Right? A little bit more. And so the answer that's close, but not exactly 30 is my correct answer, C. Okay. All right. One more. Give this one a go. So combined work problems are another place where when you've got like two agents working together, the answer choices can be really powerful. So let's use logic here a little bit. If Sabrina can assemble a tank in 8 hours, if she gets any help at all, even from someone who's like barely useful, if she gets any help, she'll be done in less than 8 hours. So there's no way that Sabrina and Janice together are going to take more than 8 hours. It's not possible, right? So we can rid ourselves of them. But we can go a step further, right? Let's imagine, if you will, that if I've got Sabrina, right? So I got my gal Sabrina, and Sabrina, one of Sabrina's, takes 8 hours. But what if Sabrina could clone herself and there were two of her? How long would it take to finish the job if Sabrina had a body double? So she was able to do twice the amount of work. Yeah, exactly. It's going to take half the time. So if Sabrina could, clone herself, it would only take 4 hours. She's the faster one, by the way, right? So it's going to take her 4 hours. So now here's the thing, is if I've got one Janice would take me 13 hours. So same logic, if I could clone Janice, it would take me 6.5 hours. Take the pair of them, 6.5 hours. The thing is that I don't have two fast Sabrinas, right? I'm not ever going to be able to get it done in 4 hours or anything under 4 hours because I don't have two fast workers. I have one fast worker and one slower worker. And so what actually turns out to be the case is that instead of having two slow workers, right, because even with two slow workers, I'd get it done in 6.5 hours. So it's got to be the case that if I've got one fast and one slow, that the actual amount of time they're going to take is going to be somewhere between those. It won't be the time of two fast. It won't be the time of two slow. It'll be somewhere in between the two. Now, that number is never the exact middle, but close enough. And the question says approximately. And so my correct answer is D. So I want you to leave tonight with this understanding that there are a lot of ways that we can work backwards. In essence, we can use the answer choices. We can use the answer choices by plugging them directly into the problem. We can use the answer choices by estimating or even benchmarking with them. Or we can use the answer choices in certain kind of archetypical questions like weighted average or combined work. Right? So what I'd love for you to do is as you're working through problems and looking at explanations, you are looking for solutions that remind you to use the answer choices, that remind you to look at them and utilize them. Because as a multiple choice test, the answer choices are an essential part of the problem solving process. We don't want to leave them for the last. They can save us a ton of work. Okay, well, if you want to come hang out with us some more, we've got lots and lots and lots of free study resources online. You can attend all sorts of classes for free. Like this weekend, we've got one of our free Foundations of Math workshops. You can come hang out with me for 5 hours. Awesome. And so you can find all of them on our website. If you go to our manhattanprep.com/GMAT/classes/free, right? You can join us for a session 1 of any of our full 9-week courses. You can attend session 1 as a trial, see if you like it, and then decide if it's something you want to stick around for. It's been a pleasure. I want to wish you all the very, very best. Thanks so much for hanging out with me this evening. I hope you have a wonderful rest of your evening. Thank you again. Take care.